Okay, good morning, everybody. Thank you very much, Roberto and Gain staff for inviting me to this summer school to present the first results of our project New Tech Aqua. I can see that you are many, so I hope that you enjoy my presentation and the information I will provide will be useful for you. This is me, as already said by Roberto. I'm a professor at the Department of Veterinary Medical Sciences. I'm a veterinary, and as a research topic, I'm a fish nutritionist, mainly working on proteins, new protein sources for Mediterranean species, and their effects on gut health and fish welfare. We work for more than 15 years on soybean meal and glutens as alternative proteins of fish meal, and now we are working on let's say more circular protein sources, as I will describe later. Yeah, I'm a coordinator of New Tech Aqua, but I would like also to inform you that the Master Congress on Fish Nutrition, which is the International Symposium on Fish Nutrition and Feeding, will be held in Italy next week. I will chair the organizing committee of the Congress, so if you are particularly interested in this topic, in fish nutrition, my suggestion is to attend this Congress, which is the most important around the world on this issue. These are the information about New Tech Aqua. Is an Horizon 2020 project, started last year, the 1st of January 2020. It will last 4 years, and the project has been founded within the same topic where other three sister projects have been founded. High efficiency. You already met Tamas, who is the coordinator of high efficiency, and then there are other two ones called Aqua Impact and Future EU Aqua. It's quite common now that European Commission in the same topic put a budget for more than just one project, and this is a very nice way to collaborate also with other groups in addition to the partners that we have in the project. So we are very well connected with the high efficiency and the other projects to disseminate and communicate and teach professionals in aquaculture sector together. The only difference is that New Tech Aqua started 1 year later than the other three projects. So I'm here just to describe the aims of New Tech Aqua and very preliminary results about the first work package on feed and feed strategies, which is the work package that we are coordinating. And where we are already carry out some trials in our lab and together with our Spanish partners, IRTA, where I can show you and share with you some approaches and methodologies that we are using to evaluate our new feed formulations that must be validated along the project. We are 26 partners. It's a very good combination between industry and academic, because we have 12 companies, private companies, where we can find very important fish farms, feed companies, software development companies, together with very important research institutes like Nofima, IRTA. As Roberto said, also University of Venice is partner of New Tech Aqua. So we are quite very well balanced between the two, let's say, area. And in this way, for this kind of projects, which are called innovation action, where we have to validate in field directly the innovation we look at, is very important to have this kind of combination between companies and academics. This is the objective, the aim of New Tech Aqua, which is quite easy, but of course very challenging. We want to expand aquaculture, which is the first point to achieve. Europe must increase aquaculture production, because production in Europe is quite stagnant. So we want to increase aquaculture production. We want to diversify aquaculture production, which means to produce more fish species, but also to develop new products, because the diversification is not just in terms of species farmed, but also in terms of new products developed. But of course, an increase in production must be done in a sustainable and resilient way. We cannot increase the impact of aquaculture production on the environment. As you may know, aquaculture, at least the offshore aquaculture, as most of the Mediterranean aquaculture and the salmon aquaculture, is made offshore. And there is no barriers between farm and environment. So every molecule or matter or contaminant or whatever you put into your farm, it's immediately passed into the environment. So it's very important, maybe more than livestock, to reduce the impact of aquaculture in terms of, for example, reduction of antimicrobials, reduction of organic matter that can be released into the environment, and so on. We work on many species, because we have 8 fin fish species, 4, let's say, traditional, like salmon, trout, bass, and bream. We have 4, let's call them emerging species, amberjack, meager, sole, and mullet. And I think that among the 4 sister projects, I don't know if I'm right or wrong, we should be the only ones also dealing with mollusks, because we also work on oyster and mussels. And then we have also some tasks also on microalgae production and the utilization for example, aquaculture for aquafeed. To obtain this expansion and diversification of aquaculture, we aim to develop different solutions, we call them, like different innovations in 6 different areas, which are the most important ones in terms of technological development in aquaculture industry. One is the Industry 4.0, we call it. I mean with Industry 4.0 precision fish farming tools mainly. One is on feed, which is the topic we will talk about today. One is on genetics, one on new species, one on new products, and one is on new sustainable farming systems. Okay, these are the work packages, but just look at the brown ones, which are the technological work packages. We merge two kinds of solutions in one work package 2, which is on production systems and the big data analysis, that we have a feed and feeding strategies, one on genetics, one on new species, and one on new products. that you have other work packages that, of course, will exploit these results, disseminate results, and with which we will train people according to the innovations that we will develop. We just finished the first period of the project. I mean, the first 18 months. And we already, of course, working on many fields. We already tested all the aqua feed formulations that we will talk about later. In Norway, we are working together with the cluster Seafood Innovation and the very big salmon farm company Mowi on a dynamic complex statistical model to predict sea lice infection in salmon through artificial intelligence models. With Roberto, Roberto, as a matter of fact, is developing a system to optimize feeding management by using different variables in terms of ammonia, oxygen, and other environmental parameters. We are testing new farming systems. On the right here, you can see Salicornia, which is a plant, a Alophyta plant, which is produced in an aquaponic system together with mullet, with very interesting results. And after that, we will test and we will farm mullet in other farming systems. And also by satellite imagery, we are also optimizing the mussel production in Spain. We are working also on genetic selection, mainly to increase resistance to diseases, both in mollusk and finfish. So in France, they are working on breeding programs in oyster to increase the resistance against the herpes virus. And we are doing the same in salmon and bassen bream in Norway and Spain. For the new species, mainly in Greece and Spain, they are working to develop, for example, new hormones, new protocols for reproduction. They are studying the behavior of broodstock in captivity to better understand the way to increase production of eggs and the quality of eggs. And also we are testing new systems to increase shelf life of fish products. There are now very innovative low energy treatments for seafood that can be utilized to reduce bacterial load, to increase, for example, the shelf life in under vacuum, to increase, for example, the shelf life of unstable matrices like means of fish or pâté or something like that. About feed and efficiency, we have, as I already said, one work package with 3 sets of feeds. These feeds have been, when we were preparing the project, discussed and decided to that together with the feed companies and farms that are involved in New Tech Aqua. So we have in this work package 2 important feed companies, Aia Veronesi, which is Italian, Irida, which is Greek, is the biggest producer of organic feeds for Mediterranean aquafeed. IRTA and University of Bologna as research institutes. And then we have two big farms, Chromaris in Croatia and Galasidi in Greece. These three sets of feeds are, the first one, we call them pro-health feeds. So feeds that are able to increase resistance against pathogens. And in our case, we are testing molecules to reduce Spiricotile infections, which is a very dangerous parasite. The second set is on, we call them zero waste feeds, are feeds that are produced without using wild-caught fish meal. So we don't use fish meal coming from wild stock of oceanic fish, which is the standard source of fish meal for aquafeed formulation. And the third set is about organic aquafeed, where we are testing new organic ingredients because there is a lack of organic ingredients to produce organic aquafeeds. These are, okay, the four tasks of the work package, but I already told you how it is divided in which kind of feeds we want to test. About the first set of feeds, I don't know if you are familiar with ichthyopathology, but at the moment, Spiricotile is the most dangerous and important pathogen in Mediterranean aquaculture, in bream especially. Is a hematophagus gill parasite. You can see it in the pictures at the bottom of the slide. This parasite can cause, of course, mortality, but also lethargy, anorexia, a decrease in growth, and an increase in feed conversion rate. And the only way at the moment to reduce the pressure of Spiricotile is a reduction of fish density in cages, which is not good for the farm productivity. And on the other hand, the utilization of disinfectants is not allowed. And especially formalin cannot be used on live fish in Europe. So the many feed companies now are developing feeds containing specific additives able to reduce the presence of this parasite in fish. So we tested at the moment the most let's say important molecule able to reduce Spiricotile infection, which is caprylic acid, which is a fatty acid, which is already demonstrated able to react against the parasite, alone or together with a mix of minerals and vitamin B, in this case, able to increase the resistance of fish against the parasite, because it is an hematophagus parasite, so able to cause anemia. So in this case, for example, iron and zinc can reduce this anemia and increase the resistance of fish. We use different inclusion rates, as you can see here. And we look at some standard parameters like final body weight and feed intake. We look at hematocrit and plasma iron. As I told you at the beginning, these results are still preliminary. We will present them at the Congress in Madeira in October, but we are still making some important analysis after the end of the trial in vivo. Then we also looking at the white cells in blood, to understand the possible potential differences in white cell quantity and quality in relation to the feeds utilized. And also we are looking at the so-called gill health, so the integrity of gills and the microbiome of gills, so the community of microorganisms on the surface of gills. All this is done to understand a potential effect on the fish health. Unfortunately, in our facilities, we cannot have parasites. We cannot make a challenge. We can experimentally infect fish with parasites. So this preliminary test is just to understand the effects in terms of welfare and integrity of gills. But in February, we started in Cromaris to test these new feeds. To be honest, as a matter of fact, 2 of them on fish in cages. So we have now some groups of sea bream in experimental cages there, which are routinely sampled to understand, in this case, unfortunately, the Spiricotilia is present, of course, to understand the effects of these additives on gill health and fish health. So the results will be ready at the end of the year. The second task is about zero waste feed. It's quite strange for us because for 15 years we work to increase the inclusion of plant proteins in aquafeed, like soybean and gluten. But now we have to reduce as much as possible the presence of these ingredients in the feed formulations. Why? Because soybean is also consumed by humans. So there is a competition between fish and humans in this case. And now the aim is to use new proteins that are not consumed, they are not used for human consumption. This is for increasing the sustainability or feed formulations. So there are millions of tons of fish byproducts available in the world. They estimated the 60 million tons of byproducts are unutilized in the world. So we wanted to test fish meal and fish oil trimming coming from aquaculture and fishery in substitution of fish meal and fish oil. This was the aim of this task, together with some new ingredients like macroalgae, yeast, and so on. This is the formulation of the 5 diets that we just finished to test. So as you can see, this C diet is the control diet with a standard fish meal inclusion of 25% and 15% of oil, which are substituted by trimming of fish meal and trimming of fish oil, here and here. Like it's not a real dose response trial because it is a mix of oil and protein sources in different ways. But this was to understand better the efficacy of these 2 different nutrient sources, fish meal for protein and fish oil for lipids. We don't have, of course, time enough to discuss in deep about the results, but if you look at the table of growth performance, it's quite interesting to see that the parameter to show the growth of fish, the specific growth rate, is quite similar among groups. But when you have more fish oil for trimming, instead of wild fish oil, you can see a sort of decrease in growth. And this is also clear in terms of feed utilization. FCR, I don't know if you are familiar with the growth parameters. FCR is feed conversion rate, which shows the kilos of feed that you need to produce 1 kilo of fish. So the lower is, the better is. In this case, we have a low FCR for the control diet, 1.34. But as you can see, here there are no statistical differences with the control diet. But after that, you can see an increase of FCR, which is not good. We are, of course, doing we are evaluating the reasons why you can see a worsening of growth parameters. We should consider that fish oil for trimming normally comes from salmon, which is farmed and fed with aquafeed, which is rich in omega-6 rather than omega-3, which are much higher in fish oil from wild fish. So the hypothesis is that in the diets with a high amount of fish oil trimming, the omega-3 requirements are not met. This is probably the reason why. But anyway, we could demonstrate that you can, for example, substitute fish meal with fish meal trimming 100% without any effect on SGR, specific growth rate, and FCR. The last task, let me see, okay, 2 minutes, but I'm also finished, is on organic fish, organic feed. There is a EU regulation on organic aquaculture with very strict rules about the characteristics of feed. And one of them is that you cannot put more than 60% of plant products in feeds for carnivorous species. But this 60% is never reached because there is, as I told you, a big lack of organic plant proteins available on the market. So we try to test new organic ingredients like organic pea protein, organic yeast, which is quite new, and seaweed. There is also now the availability of organic seaweed on the market, and we are testing these diets on trout, bream, and meager. These are the preliminary results in terms of growth. Guisante is the Spanish word for pea. We can see that the higher inclusion rate of pea determine a decrease in growth, but the low inclusion rate of pea protein, at least in trout, gave a similar results in terms of SGR, at least in trout. But something must be considered here in terms of quality of these ingredients, because as you can see a trend, a negative trend at the increasing of organic plant proteins in our diets. So this was my last slide, very easy conclusion that we already tested in lab our feeds, and next year of the project, we will validate the best diets in field, so in farm, directly in farm, as we already started in Croatia with the ProHealth feeds. And for sure, since this summer school is on ecology transition in aquaculture, of course, we can say that feed formulation remains one of the key factors, one of the most important factors to increase productivity, but also to increase sustainability of aquaculture industry. Thank you.